Hi everyone, welcome to this video lesson. And in this video lesson, you're going to learn how to multiply rationals or rational expressions. So first, make sure that every numerator and denominator have been factored completely. And then once that's done, then go ahead and cancel factors that you see that are the same on the numerator and denominator. So directions, you can cancel up, down, or diagonally. So I'm going to give you two examples for this, and I think this will be an easy lesson to understand. So for the next two examples, simplify each expression, box your answer, being sure to state any restrictions on the variables. Don't forget, restrictions means there is vertical asymptotes at those x values, and this was mentioned on the previous lesson. So example number one, what I am going to do is this first expression, I can't do anything, so I'm just going to copy it as it is. So this is x plus 2, and this is over x minus 2. Then this one here is the difference of squares, because we can factor this one as x minus 2 times x plus 2. And then denominator, we find multiples of negative 2. Since 2 is prime, the only multiples of 2 are 1 and 2. And then, so one is going to be plus and the other one's going to be minus, and we need a positive one when we add them. So that means the 2 should be plus and the 1 should be minus. So now we can cancel matching factors. So for example, this one and this one, we can cross them out. And x plus 2 and x plus 2, we can cross those out too. So in the end, what's left is x plus 2 over x minus 1. Okay, so this is the simplified version of this polynomial once we're done multiplying. But then don't forget, we must state the restrictions on the values of x. So for this one, x cannot be equal to positive 2. And for this one, x cannot be equal to negative 2. So I'm just going to say plus or minus 2. We can't have those values in the domain because that'll make this undefined. And then we can also not have for this one, x equals 1, because that'll give you a 0, so then the whole thing becomes undefined. So this is the answer to that problem. Okay, so as you can see, it's very simple. The only challenge is if you're not okay with factoring, then this will take you some time. Otherwise, this is very easy to do. So example number 2. So again, I see a difference of squares here, and I also see a GCF in this expression. So I'm going to apply a difference of squares, which is x minus 4 times x plus 4. So that's this first expression, that's the numerator of it. And then this one, there's a GCF of 2, which I'm going to factor out. So this is 2 times x plus 3. Then this one here, there's a GCF of 6, right? So then factor out the GCF of 6, and then this becomes x plus 3 instead of 6x plus 18. Denominator. Now this one is not going to be as simple. There's a 2 in front of the x squared, so that means we got to do factoring by grouping. So I'm going to do that here. So this part we do by grouping. Okay, and you can also guess and check. So then find multiples of 2 times negative 12. So multiples of negative 12 that when you add those multiples, they add to our b value of negative 5. And the only multiples of negative 12, and I said negative 12 should be negative 24. 2 times negative 12, which is negative 24. So the only multiples of negative 24 that when we add them, they add to a negative 5 are 3 times 8. So 3 times 8 gives you 24, but then we need a negative 5 when we add them. So that means the 8 should get a negative. So then this here, I have 2x squared. I'm going to group the negative 8x with 2x squared. So minus 8x, and then plus 3x minus 12. Then from these two terms, I can factor out a GCF of 2x. So, and for this, from these two terms, I can factor out the 3. So then this becomes 2x times, this becomes x minus 4 plus 3 times x minus 4. So as you can see, we have x minus 4 and x minus 4 in common. So then I'm going to come back over here, and we have x minus 4, and then put together 2x plus 3. Okay, so then now we start crossing out or canceling matching terms. So x minus 4 and x minus 4, we can cancel those two, and also x plus 3 and x plus 3 can cancel those two. And we can also simplify, this becomes a 1, and 2 goes into 6 3 times. So instead of 6, a 3. Okay, so then the answer is we have x plus 4 left, and along with this 3, so the 3 is going to be in front of the x plus 4. And then the denominator, we have 2x plus 3. Okay, so this is the product of these two rationals. Now, the last thing we need to do is state restrictions. So for x plus 3, x cannot be equal to negative 3. Okay, and then also for x minus 4, x cannot be equal to positive 4. And if we set this one equal to 0, which means 2x plus 3 equals 0, you would subtract the 3. So then 2x equals negative 3, then divide by 2, which means that x cannot be equal to negative 3 halves or negative 3 over 2 or negative 1.5. So this is the answer to this problem along with the restrictions. Okay, and that's all for this lesson. I'll see you in class. Bye.